Okay, this is day 2 on section 7.2 ellipse. You should have the pink sheet out. And this one is completing the square twice. Is there a volunteer to come up and do this one on the board? You're good. They told me you were here. This is today's.
It looks the same.
We're starting with a couple warm-up problems. How's that? If I do the first one, someone will come and do the second one? Okay. Where did I get this to? Okay, I grouped the x squareds together and took out the 4. And this 4 back here, I grouped the y's together and took out a 9, right? And then I moved this guy over to the other side. All right, so if I complete the square on the first parenthesis, what do I get? And when I squared, I put it up here, but there was a 4 out front, so there's actually 4 1s I'm adding to the other side, or just 4. And that 4 is still out front. Plus 9 parentheses. Second parenthesis, when I complete the square, I get y minus 2 squared is 4. Wow, what am I adding to the other side now? 9 4s, or 36. Negative 4 plus 36 is? Okay. Now, I would be done if this was a circle. Okay? But because there's coefficients here, it's not a circle because they're not the same coefficient. I need to figure out, it's an ellipse, to figure out the stretch, so I have to divide by 36 because it needs to say equals 1. So 4/36 is going to reduce to 9, or 1/9. 9/36 will reduce to 1/4. Okay, what can you tell me about this ellipse? Okay, this is x minus h and y minus k. I'm trying to go through this for those of you who were gone yesterday, so make sure you're... So h is 1, k is 2, so the center is at 1, 2. Now, instead of a circle where you go out the same radius in every direction, this one goes out the square root of this. That's a squared. A is 3. So it goes out 3 in the x direction. 1, 2, 3. So to find those points, if it wasn't something nice we could do on the graph paper, you would take in on the 1, because it's x direction, you would do plus or minus 3. So those are called the vertices, and they are at 4, 2, and negative 2, 2. 2, 2. All right. The co-vertices are the other direction. Underneath the y is our b squared. So b is 2. That means it goes out 2 in the y direction. To find those, what's called the co-vertices, you take that center again, but you add and subtract 2 onto the y value, so you end up with co-vertices at 1, 4 and 1, 0. And last but not least, we need to find the foci. Anybody remember the formula to find the foci? A squared minus B squared equals C squared. We had 9 for A squared, minus 4 for B squared, so C squared is 5. So C is the distance from the center to the focus, and it's always on the major axis. So we go this way a little over 2, okay, to find the focal points. So we take the center again, which was 1, 2, but onto the x we add plus or minus the square root of 5. And that's where the foci are. And when it's plus or minus some ugly square root, I said you could just leave it rather than simplifying, just leave it. If you wanted to write them both out, it'd be 1 plus the square root of 5, 2, and 1 minus the square root of 5, 2, and you could type those in and get decimals. Okay, more work than you thought, right? Anybody got number 2? Come on, be a sport, somebody. Okay, Philip, you come up and do it?
Yeah.
All right. Okay, it's Philip against the world, guys. Can you do it faster than he can?
I already did it.
That's all right, they can still beat you. Go,
All right.
go. He's got to write nicely.
I'll try. That's a 9. I do a lot of it in my head.
I guess.
Oh, you graph it too?
Yeah, but I think, look at what you just wrote.
Oh.
There you go.
That's a plus.
Yep.
Okay.
I think he's right, but does anybody need to show more work completing the square? No? Make that look so easy.
That was actually very, can't even get it on paper. Alright.
It's way easier than on the tablet. Everybody okay with where everything came from? Okay, let's write out what we're supposed to be writing out here. What's the center? Anybody? 1, 5. Okay, how do we find the vertices? What's A this time?
The Y.
Yeah, A is underneath the Y, because the definition of ellipse, A is always, or the one our book uses anyway, A is always the longer major axis one, okay? So it moves depending which number's bigger here. So A squared is 25. It's underneath here, so we're going to add it onto the Y. So we take that center, and onto the Y we add A, which was also 5, right? So where are the vertices at? 110 and 10. How long is the major axis? This is important for the next questions, guys. How long is the major axis? Major axis is the longer one. So if A is 5, the major axis is 10, right? Major axis is always 2A. So in our picture, A is 5, so the major axis would be 10. It doesn't have that on the pink sheet. And it's something you need to understand for when we go to write equations, okay? What about the co-vertices? We have to go back to 1, 5 and add what onto the x? 3. So 4, 5, and negative 2, 5. How'd I do? Okay. Foci. A squared is 25. B squared is 9. So C squared is 16. C is 4, which he did correctly. He drew them out here. But if the center was 1, 5, which one are we adding the 4 onto? And how do we know? Onto the y, because it's always on the major axis. So I have the foci are at 1, 9 and 1, 1. I will tell you on the homework check, I kind of asked for like different bits and pieces. I might say, give me the foci on number 7, give me the center on number 9, give me the vertices on number 11. Okay, so you got to have it all for all of them. Any questions so far? All right. You don't have this problem, so if you want to just watch one for a second, I will tell you this. I have a really hard time with these if I don't draw a sketch. Okay? The sketch really helps me. So this says go left 6 and up 2, left 6 and down 8. Okay? Just a really rough sketch. But if that's the major axis, what has that helped me figure out? It's vertical, right? It's longer up and down. So I can do some little sketch, doesn't really matter. How long is the major axis? I don't think so.
The one on the worksheet.
Yo, you're probably, yeah, okay. This one goes from 2 to negative 8, which is 10, right? What does that tell us? The whole thing is 10, but that means from the center, means A is 5. Okay? What else could we know? Can we find the center? Isn't it the midpoint of the major axis, or the midpoint of the minor axis, or the midpoint of the foci? Any of those would give you the center. All right, so negative 6 plus negative 6 divided by 2, 2 plus negative 8 divided by 2 gives me a center of negative 6, negative 3. How'd I do? Because they gave us both the endpoints of the major and minor, you also could have done this, guys. Right here, these both have the same x of negative 6, and these both have the same y of negative 3. Okay, so it would have intersected the major and minor at negative 6, negative 3. All right, back to writing the equation. What else do we know? All we really need to know is what now? B? Can we find B? How far is it from negative 3, over to negative 9, negative 3, the ends of the minor axis? That's a total distance of 6, so B is half that, which is, all right, B is 3. Can you write the equation? Here's the center, so it's x plus 6 squared plus y plus 3 squared. How far in the x direction? 3 each way, so what goes underneath here? 9. And underneath the y? Okay. This one is a little bit different. This is on your paper though. If you sketch this one, is it horizontal or vertical? Negative 12 and up 6, positive 4 and up 6. If that's the vertices, which are at the ends of the major axis, right? What do you know? I got people on phones, I got people doing other assignments, I got people sleeping. Okay, what's the A value? That total distance is how far? What? Okay, we could call it a diameter. It's a major axis. How far is it? 16, okay? Does that mean A is 16?
Nope.
A would be 8, okay? Can I find that middle, though? How do I find that center? What's negative 12 plus 4? Negative 8 divided by 2 is negative 4. 6 plus 6 is 12 divided by 2 is 6. So the center is at negative 4, 6, if I could write. Now what? Kind of hard to find B. They didn't really give us B, but what can we find? What does the foci tell us? Okay, it tells us C. How far C is the distance from the focus to the center. So if there's a focal point over here at 2, 6, and this was at negative 4, 6, how far apart are they? You could put the other one over here at negative 10, doesn't matter. It's a distance of 6. So C is 6 units. Now find B. B is something disgusting, isn't it? Like square root of 28 or 2 square roots of 7. Do we even care? All we really want is what? The B squared? Okay. Everybody done? Nobody has the equation written yet? X plus 4 squared. Okay, in the X direction, how far? Eight either way, which makes A 8, but the underneath here would go 64, A squared. And under here needs to go B squared, which is just what? 28. Okay, not a nice perfect square, but they didn't ask us to draw it anyway, right? Can you do that one? This one's easier, I think. Anybody want to try it? Negative 2, negative 4, negative 2, positive 8. What does that tell us? It's a vertical. The y squared is going to be bigger. So A is going to go underneath here. What else? Yep. The length of the minor axis is 10. That means it goes 5 either way. So underneath here is going to be 25. All right, what else? How long is this vertice to vertice? Negative 4 to positive 8 is a total distance of 12, so this is 6, and this is 6. So A is 6, so this is 36. The easiest thing of all, you're avoiding. The center is just midpoint, guys. Negative 2 plus negative 2 divided by 2 is negative 2. And negative 4 plus 8 is 4 divided by 2 is 2. So this one is y minus 2. You like that one better? All right. This one's not bad, except they don't give us. This is going to help us find C, and this is going to help us find A. So we're going to have to find B. Where's the center? Do that first this time for me. How do you know where the center is? Yeah, it's at the middle of the foci, the middle of the major axis, the middle of vertices, middle of everything. So if we add those and divide by 2, we get negative 2, comma. Okay, halfway there. A is 5. Yeah, I got a sketch, I think, to figure out for sure which way we're going on that. Negative 2, 1, and nope, that's not negative 2, 1. That'd be over here. Negative.
No, you got it right.
Oh. Okay, try that again. Negative 2, 1 is right there. Negative 2, 7 is up here.
Yes. Oh, yeah.
I'm gonna take a nap now.
Sounds like a good idea.
If those are the foci, though, that doesn't tell me how far out this goes, right? But it does tell me that the major axis goes that way. I just don't, it's got to be further out to the vertices. But well, the midpoint is negative 2, 4, right? The center, what's that distance? 3, which is C, because it's a foci. You get that? Okay. So C is 3. A is what? Major axis is 10, so A is 5. And it goes under which one? Up and down, so it's Y. 5 squared is 25. Now how do we find B squared? Anybody know what that's going to be? That one seem okay? All right, new concept. Eccentricity. I taught this for a very long time before I really had a clue what it even meant. Okay? I was like, you just do C over A. I don't get it. No, this is an excellent example, okay? The definition of eccentricity is the distance between the foci divided by the distance between the vertices. I want you to think about what we did on the backboard yesterday. How did I make that into a perfect circle with that string? I took the 2 pieces of tape and I put them where? Right on top of each other. So how far was it between the foci at that point? 0. So when the foci are 0 apart, or eccentricity is 0, you get a perfect circle. Does that seem okay? The further we move them, what happened? The eccentricity gets bigger because the ratio of C over A gets bigger, okay? The distance, the further the foci are apart, the more stretched out our ellipse is. All right, back here, the distance between the foci is actually 2C, and the distance between the vertices is 2A. But what happens when we do that? Yeah, we just get C over A. This definition of that is on your pink sheet, okay? E is C over A, so you get that right. But it doesn't say on your pink sheet that a circle has eccentricity of what? You got to think about that. Put those foci on top of each other and you get 0. You also need to know this one. Any ideas? Does a
1.
It is 1 because it has no, there's only one focus and only one vertex. Okay, so this is a parabola has an eccentricity of 1. What is this one going to be for an ellipse? Which is longer, C or A? Think about what they stand for. A is out to the foci, C is out to the foci, A is out the major axis. So A is always bigger, so when you put a bigger number on the bottom, you're always going to get a number less than 1 for an ellipse. And we haven't done hyperbolas yet, but when we do, it will be greater than 1. All right, so anybody have, it's called AOM, I think. What? Talk about eccentricity in that class, yes? Because elliptical orbits of planets. Okay? How elliptical is it? How stretched out is it? How close to circular is the orbit of a certain planet or whatever's orbiting? I even have a worksheet on it, but I won't force us to do it. I wasn't planning to do it. This one you don't have. I'm just going to show you really quickly. Think about this. How far out is it going this way and how far out is it going this way? Is this one stretched a lot or a little? Square root of 100 is 10, square root of 9 is 3. So one way it goes out from the center 10, and the other way it goes out 3. Pretty skinny, right? Okay. Eccentricity is C over A. How do we find C for an ellipse? A squared minus B squared equals C squared, so we get square root of 91. What's A? A squared is 100, A is 10. Type that in your calculator for me. You could leave it square root of 91 over 10 on the homework, but 0.95? Okay, what does that tell you? It's very long and skinny, not like a circle, right? Okay, I want you to find eccentricity for these two, and then I want you to decide which one's more circular. E is C over A. What do you get? 3/5, which is 0.6, or 5 over 8, which is, okay, which one's more circular? Everybody okay? You have a better idea, an understanding of eccentricity in the last 10 minutes than it took me 5 years to figure out. Like, we do this eccentricity thing, I don't know what it means. I don't know, it just wasn't clicking for me. All right, Whispering Gallery. There is a Whispering Gallery in the Capitol building, I believe. And the purpose of this is, if you stand at either of the foci, you can hear everything being whispered anywhere in the room. It says we have an ellipse that is 84 feet long and 46 feet wide. It said here it's horizontal. In the Sears Tower?
Yeah, really random place.
I've actually been in a restaurant as well that had like a domed ceiling, and if you were sitting in a certain place, you could like clearly hear the conversations at other tables because of the domed ceiling and the effect of that foci. It's kind of creepy. All right. What is this telling us, guys? If we want to write an equation, do we use 84 and 46? What's this? 42, and this is? And this one is A, and this one is B. So if we put the center at the origin, it would be x squared over 42 squared, whatever that number is. What do we get? 17 what? 64? And this one's 5 something. Did I do something wrong? We good? Okay. How do you find the foci then? A squared minus B squared equals C squared. Is it 13 something? So if you had to go stand there, you'd figure out where the center was and then go how far? About 35 feet.
Yeah, I know, well.
All right, 35.1 away from the center. Everybody okay? You could, if you wanted to state it as an ordered pair, you could have said plus or minus square root of 35, 1235, comma 0, but it doesn't really mean anything to us if we're trying to find it in that room. All right, this question is like some on the homework, so make sure you're paying attention here. They give us something weird. They give us the eccentricity and want us to work backwards and figure out the equation. What does the eccentricity help us find? C and A, right? Or one or the other, if we know one. So it says there's a sign shaped like an ellipse. So have you ever outside of a building seen somebody have a sign that was, right? An ellipse? It says it's horizontal and it's 48 inches long. What does that tell us? A is 24. All right, how can we find B or C? So 0.6 equals C over A, but what did we say A had to be? Okay, so can you find C? Okay, 14.4. Now how do we find the height? What do we have to do now? Okay, A squared minus B squared equals C squared. So we'll have 24 squared minus B squared equals 14.4 squared. So if we type 14.4 squared minus 24 squared, and then we change the sign, we get 368.64. So could we write the equation right now? X squared over 24 squared. Anybody have 24 squared written down? I should have known that one. Y squared over 368.64 equals 1. But b is the square root of that. What is the square root of that 368 number? 19.2. Okay. What's the height of the sign? And it's not 19.2. Okay. Make sure when you go to do the homework, you look at that example again. Right, Gannon? You okay? So that you remember to double it, because I would have forgotten otherwise if I didn't draw the picture and really think about how tall it is. Everybody okay? All right. Couple really quick questions. This one says there's half of an ellipse. At parent conferences, I decided to mention to the math staff that I thought there was an ellipse on the floor in the commons. Those two eatery places that face like the school store, if you ever see on the floor, there's either half of an ellipse or half of a circle on the floor right there on the tile and on the ceiling. We were debating whether it was an ellipse or a circle, but this says it's an ellipse. It says it's 5 feet all the way across. It's the headboard of a bed. It's 5 feet all the way across. So what's A? Okay. And it's 2 feet high. Yeah, it was nerd central there for a minute. All the math teachers got up to go out and debate whether they thought it was a semicircle and ellipse. Then we realized what nerds we were being. Okay. Where's the foci? So he needs to figure out where the foci are so that he can measure this. So we need to figure out where C is out here. A squared minus B squared equals C squared. So how would he locate it? What'd you tell him? Yeah, from the center, or in this case, he really could go in 1 foot from the edge, right? But I think that's what they were looking for. All right, super easy last question. Circles. How many years have you had circles? Too many. Okay. This circle has a radius of what? 200. Says sketch it. So it's counting by 50s. So 200, 200, 200, 200. Okay. It also says find the distance from the center to the house, from the center of the pond to the house. If the radius is 200 and this is 700, how far is it from the center of the pond to the house? Okay. The pond is flooding. The radius of the pond is growing 100 yards per day. So how long until it hits the house? Got a little more time than that. It's got to go 700 and it's going 100 a day, so it's 7 days? All right. Write an equation of the circle as it is right now. What's that equation, guys? If it's at 0, 0. What's the radius? Okay, whatever that is, 40,000 or something. I don't know. Got a lot of zeros. Okay. Write an equation of the circle when it gets out here to the house. What would its radius be then? X squared plus Y squared equals 900 squared. All right, yes. All right. Assignment. Few odd problems, few writing equations, few applications mixed in. Do not get behind. The homework check is Friday, and we are covering new material both tomorrow and Thursday on hyperbolas. Yay?